Hi, how y'all doing? All right, I am going to demonstrate like number 11 for marking period 4, multiplying radicals day 3. Try to get you started here. And what I've done is I've taken kind of like a snapshot or a snippet. On your Chromebooks. You can do Control Shift Show Windows button. The Control Shift Show Windows button should be able to grab you. You could be able to grab a partial little clip of this stuff, just like I've done, and then just kind of paste it on in your answer sheet so that you can answer these. All right, so that way you don't have to flip back and forth. Just my recommendation. You don't have to do that, of course. If you don't mind flipping back and forth, that's up to you. Let me give you an idea of how to do this on paper. Now, I'm going to demonstrate how to do this in one line, but I just want to give you the general idea on paper. So the problem is we have these parentheses here. These little parentheses here are implying multiplication, which means this whole everything inside the parentheses over here is one expression, and then everything inside the parentheses over here is another expression. And these things are getting multiplied to each other. The problem is that we have some things that kind of separate the multiplication process inside the parentheses. This plus means I'm going to need to distribute this whole expression across each piece of each one of these expressions, right? And this minus does the same thing. So here's kind of how this plays out. Let me kind of delete what I've got here. All right. So it's kind of like when you are multiplying polynomials and things like that. I'm going to take this piece here, all right, the first half of the first expression. I'm going to multiply it to radical 3. Then I multiply it again to negative 5. All right, so let me start with that. What is negative 2 times radical 3 times radical 3? Okay. Well, first we got to know what is radical 3, and why is my thing is not working out too well today. Let me try that again over here maybe. What is radical 3? Radical 3 times, why is it not? It doesn't like me today. Time. You gonna do anything for me? Maybe I need a bigger pencil or something. Maybe I'll try this. No, it just wants to be weird today. Let me try something. Green? There. Now it reads it. Oh. Okay. Times radical 3. Radical 3. I'm having problems. Okay, well, radical 3 means find the number that multiplies to itself to give you 3. All right, that's what if we go to our calculator over here, math machine. Let me turn my math machine on. Let me give you an idea of what's. Oh, I got to move my face. Okay, our math machine can actually do this. Second, you see that square root symbol, that radical symbol there? There's my square root or radical symbol. I can put 3 in there, and I can actually find the decimal number. The problem with this decimal number is it's a oh shoot, it's irrational. It's an irrational number, right? And they call it irrational because it has no termination point. It just gives you all these weird numbers indefinitely. But the thing is that radical 3 is the number that multiplies to itself to give me this here. So, but if I multiply this number, I take this number and I square it, I times it by itself, I get 3. Now you can ignore that little 1 there. That's just the calculator's rounding, right? So that means that radical 3 times radical 3, if I go back to my writing, is just plain old 3. Okay? So really what happens here is that it becomes this negative 2 times radical 3 becomes negative 2 times 3. And what's negative 2 times 3? That's just 6. Actually, not just 6, it's negative 6. So negative 6. Okay. Part 1 done. Now I got to take negative 2 times radical 3 and times it by negative 5. Well, I can take the negative 2 and the negative 5 together. They can become positive 10. Remember, a negative times a negative become a positive. So that becomes positive 10. So this is going to be a plus 10. And then on my key, I got to keep my radical times. The 10 is going to be times radical 3. Okay, that's just the first part. Woo, I got more to do. Now I got to take this 2, and my pen doesn't want to work, and times it by this, and then times it by this, right? Oh, sorry, I shouldn't have done that. This times that, and then this times that, all right? This times this time. All right, so 2 times radical 3 just becomes 2 times radical 3. There's nothing for us to do there. Nothing for us to do there. And then 2 times negative 5 becomes negative 10. And I can add these two together because they're both under the same radical. This is radical 3. This is radical 3. I can add them together to become 12 times radical 3. 3. So I have a final answer. Let me change my color to get my final response in here. Do I want to do it? All right. I have my negative 6. Oop, and I can combine that with my negative 10 to become negative 16. And so I have 12 times 12 times radical 3 minus 16. That's kind of how we play it, all right? That's the general idea. So now that you've kind of seen how to imagine this if it was done on paper, let me try to show you how you do it kind of in the annoying Google Doc way, which is called math in one line, right? This is the math in one line technique. All right, so I'm going to do a couple things here. First, I'm going to do negative 2. I need my radical sign, right? I'm going to insert special character, square root. There it is. Boop. Now it's in there. And then I'm going to select that and just Control C and copy it, so I can keep writing this anytime I want it. 3, and I'm going to multiply that by radical 3. So what I've just done is I've written this out and said, hey, I'm going to multiply that by radical 3. I'm going to find out what that is. All right, and then I'm going to find out what negative 2 times radical 3 times negative 5 is, right? I'm doing that, doing the first part of the expression times the negative 5. Oh, that. All right. Sometimes machines don't like to play nice, you know? Sometimes you press the wrong key and, sorry for coughing at you. Okay. Now I'm going to do 2 times radical 3. 2 times radical. It would help if it was typing. 2 times radical 3 equals. And then 2 times negative 5. 2 times negative 5. Okay, so now let me get my answers to all these. I'm going to add all these up when I get them done. Negative 2 times radical 3 times radical 3 just becomes negative 2 times 3, which is the same thing as negative 6. Remember that? I got negative 2 times radical 3 times negative 5, which just becomes positive 10 times radical 3. And then 2 times radical 3 just becomes 2 times radical 3. And then 2 times negative 5 becomes negative 10, right? Because I have, not negative 190. That's what I want. Negative 10, because positive 2 times a negative 5 gives me a negative 10. 2 times 5 is 10. A positive times negative is a negative. Okay, now I add all these together, right? I can combine the negative 6 and the negative 10 to be negative 16. And then I can combine the positive 2 and the positive 10, because they're both of the same radicals. I can only do this because they have the same radicals. That's what allows me to be able to do that, to be 12 radical 3. And then I'm done. That's my answer. That's my answer. Where's my highlighter? There we go. Give me a nice green highlight. Make it pop out for whoever looked at that. All right. Number 22 now. Number 22. So I'm just going to kind of do what I just did a second ago. I'm going to do 5. See the 5 here? Times negative 2. 5 times negative 2. I'll find out what that is. Then I'm going to do 5 times radical 5. 5 times radical 5. What is that? Then I'm going to do negative 4 times radical 5 times negative 2. Okay? Negative 4 times radical 5 times negative 2. I'll find out what that is later. And then I'm going to find out what negative 4 times radical 5 times radical 5 is. Okay? Negative 4 times radical 5 times radical 5. Okay. I've got my 4 pieces. Is there any of these that have more than 2 pieces? No, everything's got 2 pieces. So there'll be 4 calculations that you'll add up and combine in the end. Well, 5 times negative 2, that's just negative 10. 5 times radical 5 just becomes 5 times radical 5. Nothing for me to do there. I can't, this is a number, but it's an irrational number, so I'm just going to keep it in its radical form. And kind of we keep it. Why do we keep these in radical form and not just make them a decimal? Well, if you had to come up with an actual number, you'd come up with an actual number. But because you can, with an irrational number, you always have to round. Keeping it in the radical form makes it the more precise way of saying it. It's more concise and more precise. If I give a giant rational number, no matter what, I'm going to have to round somewhere because the rational goes on forever. Also, there are convenient things that happen that you may not notice with if you keep everything in the kind of a decimal form. Is that like -4 times radical 5 times radical 5? You might not have noticed that that's just going to be -4 times 5, right? You're going to get if you were to actually put this into your calculator will give you an answer. It will find you a decimal number for this -4 times radical 5, right? You can actually put this in your calculator. You can get this crazy irrational number going on, and then you can times that by, radical 5, and you might not notice that this is going to be -20. You may not have noticed that. But if you keep it in radical form, you do notice that it's that. So another reason to keep it in radical form. And then, so this is going to be -2 times the coefficient out in front, -4. That gives me a +8. +8 times radical 5. And now I can combine what I can combine my like terms. Okay, I'm going to combine this one, the -10 with the -20. That's easy. That becomes -30. All right. And then I'm going to combine, okay, I have two expressions that are both being multiplied by radical 5. I can combine these. 8 plus 5 is 13. So 13 times radical 5 minus 30 is going to be my answer. And now I need that. Where's that fancy green? I like that green. There we go. Makes it pop. Makes it pop. All right. Let me see. Let me do 26, and because sometimes maybe the last ones are harder. I'm not going to do 23 and 24 at all. Just trying to see if there's anything super hard going on here. Oh yes, there's some variables going on, so I do want to do these. Okay. The variables sometimes make it a little bit more difficult than it has to be. Let me start. I'm going to do -3 times radical 3k times radical 3k. All right, so radical 3 times radical 3k. Well, technically, I probably should use parentheses or something. I don't know. But I'm not going to bother. I'm just going to remember that's underneath the radical. Times radical 3k. Find out what that equals. Then I'm going to find out what -3 times radical 3k times -5 equals. All right, so -3 times radical 3k times, what was it, -5, I believe. I'm going to find out what that equals. Then I'm going to do +4 times radical 3k. All right, now next step, +4 times radical 3k. I'll find out what that equals. And then I'll do +4 times -5. That's an easy one. +4 times -5. Okay. Ooh, I need a negative in there. You forget a negative and everything messes up. Okay. Did I do everything right? I hope so. Let me try to take a look. Okay, well, this is great. This becomes -3 times, what's 3k times 3k? 3, right? Oh, 3k, sorry. No, 3k, 3 times k is a number I don't know. Whatever that number is, the radical of that times the radical of that gives me 3k. It gives me that, right? So I can't do anything more with this other than to say maybe swap it around. I would like to put it in standard form, call it 3k minus 3. All right, let me look at this one. -3 times radical 3k. Okay, well, I'm going to take the coefficient -3, multiply it by -5. That becomes a +15. And that +15 is going to be multiplied by 3 radical 3k, or the square root of 3k. All right, now 4 times radical 3k. There's not much I can do there. 4 times 3k. That just becomes that. And then, of course, the easy one is 4 times -5. That's going to be -20. I'm going to cough at you again. Pardon me. Okay, now I'm just going to combine what I can combine here. I can combine these two things. I can make this to be 3k minus 20. 3k minus 20. And then what else do I have? I combine, because these are both radical 3k, being multiplied, I can add them together, so that becomes 19 times radical 3k, and then it's going to be plus, no, not equals, plus, there we go, 3k minus 20, and that's it. That's as far as I can go. I can't do anything else there. It's going to look ugly. That's all it is. Now I'll put a little green highlighter on there. All right. And I'm tempted to do 25 because it's got those variables, but you know what? You need to try one of those variable ones on your own. So I'm going to leave you with the rest of these others to do. All right. Get to it. You can do this. I'm Mr. Solt, and I'll see you in class.